Okay, this video is to explain the converse of the Pythagorean theorem. You should have this worksheet printed out or be ready to at least take some notes on the stuff that's here, or scratch a piece of paper so that you can work out the problems on this. So the top part is a bit of review, so hopefully you watched the previous notes on the Pythagorean theorem worksheet, and you can be able to answer these questions at the top now. So the longest side of a right triangle is called the hypotenuse and is always found opposite of the 90-degree angle. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangle, and c is used to represent the hypotenuse. So, remember, the hypotenuse is always, as it says here, the longest side in the triangle. We have to make sure that we label that one correctly when we're using the Pythagorean theorem. The other two, a and b, remember, not as important because a squared plus b squared appears on the same side of the equation. It's okay to mix those up. So the converse of the theorem, it says here in math, a converse of a theorem says that reversing the statements of the theorem will in turn prove another theorem. So for example, when it rains, the grass becomes wet, can be reversed to give the theory of the grass is wet, therefore it must have rained. So the Pythagorean theorem states that in a right triangle, the sum of the two squares, or the squares of the legs, the two legs, of the triangle, will be equal to the square of the hypotenuse. So therefore, its converse would state that if the sum of the squares of the two shortest sides of the triangle is equal to the square of the longest side, then the three sides must create a right triangle. Okay, so we're basically using the fact that if we're given three sides of a triangle, and we know the Pythagorean theorem can only be used with right triangles, if we can substitute our side lengths into the Pythagorean theorem and make it a true equation or a true statement, then it's going to prove that those three sides would make a right triangle. Okay, so for our examples here, number one, we have sides of 7, 20, and 12, and we're determining if the following lengths of sides could create a right triangle. Once again, if we envision this as a triangle, and if it were to be making a right triangle, again, the longest side is going to have to be C, and in this case, that would be our 20, because that's the longest of our three legs. So that would have to be C. For A and B, in this case, we have side lengths or legs of 7 and 12. And so if this were to make a right triangle, this would have to be the setup. So to test to see if it would actually hold true, we're going to substitute again into the Pythagorean theorem, which again is our a squared plus b squared equals c squared, where for this triangle it would be 7 squared plus 12 squared that would have to be being equal to 20 squared. Okay, so now we're basically just going to evaluate the equation and see if it is a true equation or not. So 49 plus 144 would have to equal 400. So if we add up the left side of our equation, here we get 193 equal to 400, which is not true. And so therefore, our answer here is simply a no. This would not make, these three sides would not make a right triangle. Okay? Repeat the process for number 2. So we've got triangle side lengths of 15, 8, and 17. Again, C is the most important. That has to be our longest. So in this case, 17 would have to be C. A and B then, the shortest of the legs, A, and then b being used for the 15 here, the middle length. So substituting that in to the Pythagorean theorem, we would have 8 squared plus 15 squared would need to make 17 squared. Okay. So that would be 64 plus 225 would have to make, I believe, 289. Yeah. Okay. Add our 64 and 225 together. And this time, we do get a true equation. So 289 does equal 289. And so therefore, on this one, the three sides of our triangle of 8, 15, and 17 would make a right triangle. Okay, so that's the concept and idea there of the converse of the Pythagorean theorem. On the back side, a worksheet where, starting off, we're stating whether or not these triangles would be right triangles. Now, they all appear to be making right triangles, but we're not going to assume that they're definitely making right triangles. We could see that if this was going to be a right triangle, that our right angle would be here in the triangle, but we're not guaranteed that necessarily these lengths make a right triangle. We can't assume that the figures are drawn to scale. So again, we have to use the idea of the converse of the Pythagorean theorem to test whether it is or is not a right triangle. So if I were to label this triangle, that would be the A, B, and C for the triangle. So in the Pythagorean theorem, we would get 5 squared plus 15 squared equals 17 squared here, which would be 25 plus 225 would have to make 289. That only gives us 250 though. And so for this one, it's a no. That would not make a right triangle. Okay, one more example of those. So label the triangle. Again, if this was going to be a right triangle, this would be where the right angle is in this triangle. We have C being the 5, the longest of the lengths, and then A and B, 3 and 4. Okay, substituting it in the Pythagorean theorem, it would say that 3 squared plus 4 squared would have to equal 5 squared. That would give us 9 plus 16 would have to make 25, and 25 does equal 25 in this one. So this would be a yes. Okay, and then the other part of this worksheet is finding a missing side of the triangle, rounding our answers to the nearest tenth if necessary. So this is what we practiced from the notes and from the other worksheet. So again, start off by identifying which side is going to be C. Here's my 90-degree angle. I'm going to look straight across from that to find the hypotenuse. So in this case, we're missing the hypotenuse of this one, so there's C. A and B, substitute it in the Pythagorean theorem, and solve. So 12 squared plus 16 squared would equal x squared. 144 plus 256 equals x squared. So in this case, 400 equals x squared. Take square root of both sides, and for this triangle, x is going to be equal to 20. Okay, one more example there. In number 9, this time we're given a length for C, our hypotenuse. It looks like we're missing the shorter of the two legs, so A is our unknown, and so we would get x squared plus 17 squared equals 18 squared. Okay. It's 324. Two-step equation now. We get that x squared is equal to 35. Square root both sides. And let's see, that's going to be just a little less than 6. The square root of 35, and so sure enough, 5.91. So we'll round that, it says to the nearest tenth, so we'll go with 5.9. Okay, so hopefully that gives you an idea on how to complete the rest of this worksheet. There'll be questions similar to both of these sections on the quiz. Let me know if you have any questions about things.